Good morning, ladies and gentlemen. Today we're going to look at several geometric properties. You'll have seen all of these before. You'll probably think of them as assumed knowledge or just stuff you already know, but it's worth having them in your notes just in case you have that terrible mental blank in the exam. Starting off with parallel line properties. Alright, start off with is alternate. Alternate is the Z1, if you want to remember it that way. It states that this angle and this angle here are the same. Alternatively, this and this are equal, or even strictly speaking, this is equal to this because of alternate. You can still see how it's opposite sides of a Z almost. Or finally, you can say that that angle is equal to this one. So, same color, they're equal. Note that the line passing through them all, this line here, is called what's called a transversal. Good word to know, because sometimes they'll describe a pair of parallel lines and a transversal line. It is confusing unless you've seen the word transversal before. Alright, corresponding is the F1. This corresponds with this. They are equal. Similarly, this angle corresponds with this one. You can see it's the inside of an F there. They're equal. Similarly, this one, and the last pair as well would be, which color I haven't done yet, this one and this one. Alright, those two are quite simple. This one here, a little more complex, co-interior. Co-interior, they add to 180. So a pair of co-interior angles would be this one and this one. Note, I haven't made them the same color because they're not the same angle. And you can see by looking at them, they're not the same angle. But if you add them up, they equal 180. Alright. Other properties. General angle properties. If two angles are opposite each other, say there and there with a pair of cross lines, they are equal because they are vertically opposite. Similarly here, if you have a line joining another line and you know that one side is theta, the other side will be 180 minus theta. And that's called supplementary angles. I've spelled that wrong. Only one P, I think. Supplement. No, two P's. Finally, angles inside a triangle add up to 180. Fairly easy. And speaking of triangles, let's go on to triangles. Keep adding to your notes. Properties of triangles. We all know they add to 180. So A, B, and C here add to 180. What you may not know, although it would be easy enough to logic out, is that D is equal to the opposite angles inside the triangle, A and B. Alright, and that does come up occasionally, so worth just noting that down. Alright, an equilateral triangle has equal degrees and three sides that are equal. So 360s and three equal sides. And interesting properties of them, if you cut them in half, you form right angles and you exactly bisect the opposite side. Isosceles triangle has two sides equal and the base angles are equal. So this red dot and this red dot, they are equal angles. Now this is quite often comes up in Pythagoras style problems because if they ask for the height of the triangle, you drop a line down here, it forms a right angle, and you bisect the base, meaning you cut the base in half, half there, and you set up a right angle triangle like that. Alright, properties of polygons. All of these are what's called regular polygons. Polygons meaning multiple sides, regular meaning they all have the same interior angles, as in that's equal to that's equal to that's equal to that's equal to that, or this is equal to this and this and this and this. All of those angles will be the same with inside a shape. Alright? And you should know the names of the shapes up to octagon. Now, the sum of the interior angles is given by 180 multiplied by n take 2. So if you have three sides in a triangle, you have the sum of the interior angles equal to 180 multiplied by 3 take 2 is 180 times 1 is, well, just 180. That rule applies for all regular, in fact, all polygons, not just regular ones. So you can work out the angles inside a polygon using that formula. Last thing, unit conversions. Now, I know you all know this, but please write it down because so often, and do check it in the exam, so often it's very easy to say under a lot of time pressure, 3 kilometers is, yeah, it's about 300 meters, and just do that. It's so easy. 300 kilometers is not 300 meters. 3 kilometers is 3,000 meters. You get it, I'm sure. But Nice easy way to remember is to do one of these flowcharts. Essentially what this is saying is that if you have it in centimeters and you would like to go to meters, what you need to do is divide by 100. And we'll do some practice of this in class just to get a head around it. Kilometers to meters, you multiply by 1,000. Now note, this is only when we're talking about length. Area is something slightly different, and here's why. This is 1 meter squared. Easy enough, because that's 1 meter by 1 meter. Now we saw up above, to get from meters to centimeters, we multiply by 100. So often with area, people tend to think we'll multiply by 100, and that 1 meter squared is equal to 100 centimeters squared. But let's see if that's right or not. 1 meter is certainly equal to 100 centimeters. 1 meter is equal to 100 centimeters. And if we want to work out what the area of the triangle is, area of the square is, area equals length times width, or in our case, 100 times 100, we know that area is equal to 100 times 100, 10,000. So, interestingly enough, 1 meter squared does not equal 100 centimeters squared. 1 meter squared equals 10,000 centimeters squared. And understanding the logic behind that's important. The flowchart for this looks like this. Area, we remember, has squared units. So it's exactly the same as the length one in terms of 10, 100, 1,000, but this time we square it. 10 squared, 100 squared, 1,000 squared. So the conversion we just did below looks like this. 1 meter squared is 10,000 centimeters squared because we're using this 100 squared tool to get between the two. Similar logic applies to volume. Cubed, 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 cubed. So please have those 3 tables down. Now, extra weird units that we see occasionally. In terms of volume, when we say measure the capacity of it, we're talking milliliters, liters. Volume, for some reason, is centimeters cubed. Capacity is how much a container can hold, and therefore it's the liters amount in there. Alright, 1 milliliter is exactly 1 centimeter cubed for a further student. Yes, physicists, I know. But that's what we go with. So therefore, 1 liter is 1,000 milliliters. 1 liter is the same as 1,000 centimeters cubed. You should also know that 1 kiloliter, KL, is equal to 1,000 liters. 1 megaliter is equal to 1,000 kiloliters, etc. In area, there's another weird option here called hectares. Hectares come up quite often. It's how we measure our farms. A hectare is 100 meters by 100 meters. So 1 hectare is equal to 10,000 meters squared. Alright, that ends the video. Pile of notes, not a lot of explanation, but hopefully you'll survive. Thank you very much.